Hello, this is Ms. DB. In this video, we are going to look at solving equations using mental math. And we will work more with solving equations through the rest of this course, but this is just kind of an introduction. So we're going to be solving simple equations with just one step, with addition or subtraction. So in this first section here, here's an example from your textbook. It says y plus 10 equals 15. So there's an equal sign. Equations have equal signs. And the equal sign tells us that y plus 10 and 15 have the same value. So what we're really doing is trying to figure out what could y be so that when you add 10 to it, you get 15. So we just kind of think about it and we say, well, if we have some unknown that we'll call y, and we're going to add 10 to that, we need to get 15. So you might think of this as being a box with an unknown number in it, and you need to figure out what is in the box. So in this problem, you probably already figured out that 5 is the missing number because 5 plus 10 would be equal to 15. So that's what we call using mental math. That doesn't mean that you can't use a calculator to check your answers or to try to figure out the answer. That's just fine to do that. So your problems are right here, and what we're going to do is just try to figure out for each problem what is the missing number. And when you figure out what the missing number is, you're going to write that variable equal to your missing number. So we won't just write the answer 5, we'll write x equals 5, because that's the way we do it in algebra. We name the variable and then we say what it is that we figured out that the answer would be. So let's look at one that maybe looks a little bit harder. Let's look at number 9. Number 9 says 17 plus a is equal to 23. So 17 plus some unknown number that I don't know what it is, some mystery number, is equal to 23. So I don't know off the top of my head what plus 17 equals 23, but I can count. I could say, well, I know there's only a few more to get to 23. I could add one more and get to 18. I could add one more and get to 19. And I could keep going until I get to 23. That would be one way to solve this. I'm going to run out of room. So I added 1, 2, 3, 4, 5. And then I could check and see, is that right? Is 17 plus 5 equal to 23? And no, I didn't add enough. I needed one more, because 7 plus 5 is 22. It's not 23. So I actually needed to add 6. So this just shows that you need to be careful and you need to check your work and make sure that you have the correct answer before you say what it is. And again, once you figure out the answer by whichever method works for you, then you would write a equals, and then you put your missing number in. Now like I said, we're going to do more of these later, where we'll solve these problems by using inverse operations. So just as a little sneak peek, we would solve number 9 by subtracting 17 from both sides, and then we would get a equals 23 minus 17 is 6. So if you've done problems like this before using that method, inverse operations, you can go ahead and use that as well. On the next section, there is a number and something was subtracted from it. So it's very similar, but it's a little bit trickier because we have to figure out what is the missing number that when you subtract a number, it's equal to, in this case, 10. So again, our mystery number is our variable, in this case, x, and we are going to subtract 5 from it and figure out what must that number have been, so that when we subtract 5, we get 10. And in this case, it was 15. So you would write x equals 15 as your answer. And then you'll do some more problems like that where you're trying to figure out the missing part of a subtraction problem. Then in the next section, there's multiplication problems. So you need to figure out what number times your missing number is equal to some number. Like let's look at number 17. says 6 times x, so x is our missing number, is equal to 48. And we need to figure out 6 times what? 6 times what equals 48? And you might not remember your multiplication tables, or maybe you do. 6 times 7, nope, that's 42. 6 times 8, that's the one. 6 times 8 is 48. And then you can check it on your calculator. Here's my calculator. 6 times 8, it is 48, so that is the right number. So I would write x equals 8 for my answer. And then on the next section, you have some problems with division. Now this looks kind of like a fraction, and it is, because fractions are division. In this problem, these might be the easiest ones to do. We are really just going to have to figure out what number divided by that number is equal to the given number. So x divided by 4 equals 5. I'll give you a hint on this. The easiest way is just to multiply your two numbers together, and that would give you 20. 20 divided by 4, let's check and make sure. Does that equal 5? It does. So we would write x equals 20. So this bar here means division. So these problems are all division. You have to figure out the missing number, and the missing number so that when you divide it, you would get the other number on the other side of the equal sign. So in 27, it says there's some number divided by 8, and you end up with 9. What number divided by 8 equals 9? And again, the trick on these, if you can't figure out what number divided by 8 equals 9, is multiply these two together. That's called inverse operations. And then you would see that that is 72. So do your best on these and exercise that brain. And if you get stuck, use inverse operations or use your calculator or check in with me. Thank you very much and have a wonderful day.